All right, we have section 7.6, which is called adding and subtracting polynomials. I think you'll find this the easiest section of the 4 that we're doing for this test. I also think you'll find it easy to see what I'm writing because I'm actually using a marker that you can see. And I have backup markers. So everything should go better this time compared to when Mr. Dugan was here that one day. I did steal these from Coach Lynch, so I'm recording this before the sectional, so if Coach Lynch is looking for a marker on the sideline, don't rat me out because I kind of took his markers from him. So let's see here. So we're going to take a whole bunch of polynomials and add them, a whole bunch of monomials and add them, I should say, maybe like 5 or 6 of them. And then we also might take like a trinomial plus a trinomial, or a 5-term polynomial plus a binomial, or something like that. And it sounds kind of scary, but it's not. Okay, it's pretty easy. So, all right, let's look here. Let's add up a bunch of monomials and see what we can have happen. So let's do 4m squared minus 3m to the 4th plus 7m minus 9m to the 4th minus 10m squared. So I have a monomial minus a monomial plus a monomial minus a monomial minus a monomial. So I have 5 monomials that we're adding there. Well, hopefully you remember. I'm going to clear my throat. Hold on a second. There we go. Hopefully you remember that like terms not only have the same variable, but that variable has to be to the same power. Or I guess now, since we know what the word means, we can say they have to be the same degree. So m squared and m to the 4th are not like terms, but m squared and m squared are. So let's go ahead and combine those. 4 minus 10 will give us negative 6. And nothing happens to the m squared, like it doesn't become m to the 4th or something like that, right? Like if you were taking 9 apples plus 6 apples, you wouldn't say I have 15 apples squared all of a sudden. You still have 15 apples. Well, we still have m squared when we get done combining those like terms. To the 4th and to the 4th. Now those are negative and negative, same signs, keep and add. And then we got this linear monomial hanging out there. Now, we're not done because all answers on the homework, on quizzes, on tests need to be in standard form. Standard form, we learned what that was last Thursday when I was still here in person. But standard form means we will write these on a term-by-term basis, going from the highest degree to the lowest degree, descending order. So degree 4 is the highest degree, then degree 2, and then degree 1. So we end up with a quartic trinomial as our answer, whose leading coefficient is negative 12. Okay. Now I'm not going to take the time to do this, but it is true. Like if I let m be equal to 2, I could plug 2 in here, 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 and here, multiply all that out, add it together, and I get some number, whatever that number is. If I let m be 2 down here, I should get that same number. In other words, these are equivalent statements. Okay, they're equal to the same thing. This one is just simplified, cleaned up. Let's do one more of those, and then I think that'll suffice. Let's do 9x squared y squared minus 3x squared y plus 2xy squared minus 5x squared y squared plus 7x squared y. All right, x squared y squared and x squared y squared. These are like terms. 9 minus 5 is 4, so I get 4x squared y squared. So those are done. X squared y and xy squared are not the same. X squared y and x squared y. So we have a negative 3 and a positive 7. That'll give me positive 4x squared y. And then I'm left with 2xy squared. Okay. This is degree 4. You have 2 x's and 2 y's. That means you have 4 variables, so it's degree 4. Degree 3, degree 3. If you multiplied this out, it would be xxy, and this would be xyy. So alphabetically, this one would come first. So this, in other words, this is already in standard form. All right. So enough of that, of adding a whole bunch of monomials up. That's kind of boring. Let's add something besides monomials. Let's take a trinomial plus a, we'll just do another trinomial. Now, this looks complicated and scary. It's not. It's not at all. Technically speaking, you're taking one trinomial plus one of these trinomials. In other words, we're using the distributive property there of a ninja 1. And you got 3x squared minus 4x to the 5th plus 3x. And then you're going to distribute this one. We get minus 9x squared minus 4x to the 5th plus 7x. Now technically, we just distributed that 1 there. Big deal. I don't really care. I just wanted to show you that because I'm going to use that in an example later where it's a little more important. Don't worry about it. Just drop the parentheses. Anytime there's a plus there, drop the parentheses, and then move on to combining like terms. Now this looks like the first example that we did, or looks a whole lot like it, I should say. So we got 3x squared minus 9x squared, that's negative 6x squared. Negative 4x to the 5th and negative 4x to the 5th, those are same signs, keep and add. I get negative 8x to the 5th. And then 3x and 7x give me 10x. It's not in standard form yet, though. I got to take degree 5 and move it out to the front, then degree 2, then degree 1. So I end up with a quintic trinomial. All right. Let's add another one. Let's do 4x to the 3rd plus 3x squared minus 7 plus 9x squared minus 8x minus 2. So I have a trinomial plus a trinomial again. I guess I could have changed that up and had a 4 term plus a 3 term, but it's the same thing. I'm not going to do the ninja 1 and distribute this time. I just want to show you that once for a reason. In the next example, you'll see why. Just drop the parentheses. So the parentheses are going to go bye-bye. And again, I can do that when it's addition. I can drop them from here and from here when that's addition. So now I get plus 9x squared minus 8x minus 2. And now it's time to go collect things that are alike and combine them. This is the only cube, so just drop it down. 3x squared and 9x squared, that is 12x squared. negative 9 and negative 2, I'm sorry, negative 7 and negative 2 are negative 9. Had the answer in my head and said the wrong number. And then minus 8x, 3, 2, 0, 1. So these need flip-flopped around. And now it is in standard form, and I end up with a cubic polynomial. Right. Let's do a trinomial. Nah, I'll keep doing trinomials. Let's do a binomial minus a binomial. Now, for the first time, I have a minus sign here. If I put my Ninja 1 there and distribute, that'll be just like dropping the parentheses again. So I'm just going to drop the parentheses off this one. But if I put my Ninja 1 here, I'm not distributing a plus 1, I'm distributing a minus 1. So what ends up happening is we get negative 1 times 4, that'll be negative 4. And negative 1 times negative 5, that'll be positive 5. So the signs end up switching. This positive becomes a negative, and this negative becomes a positive. X and negative 4x give me negative 3x. And then negative 3 and positive 5 give me a positive 2. So I end up with a linear binomial there. All right, let's do 7x squared minus 3x cubed plus 2x minus 4 minus negative 3x squared minus 8x plus 5, let's say. All right, this is a positive 1 in front of that, so I can just drop the parentheses on that 4-term polynomial here. But this is a negative 1, so I can't just drop the parentheses. Oh, distributing that one twice. I have to distribute that negative 1. Negative and a negative make a positive. Negative and a negative make a positive. And negative and a positive make a negative. Squared and squared, that'll give me 10x squared. No other cubes besides this one, so I'll just drop that down. X and x give me 10x. And then negative 4 and negative 5 give me negative 9. This is 2, 3, 1, 0, so I have to switch the 2 and the 3 around. Degree 2 and degree 3, I mean. So I get negative 3x cubed plus 10x squared plus 10x minus 9. All right, I'm going to show you something that seems random, but you'll have to use it in one problem from your homework, which is number 15 on the homework. Let's take an angle and label these points A, B, and C. Now, in geometry, next year, you could call this angle B since it's the only angle there. Or you could call it, that's shorthand for angle. Or you could call it angle ABC, because if you go ABC, you make that angle. Well, if I add another ray there, I can no longer refer to one of those simply as angle B, because B is in the middle of two angles now. It's in the middle of this one and this one. I guess technically in the middle of 3 and the one that makes up both of them combined, okay? Well, what you need to look at for this is something called, I think it's called the angle addition postulate, which is really fancy for saying that if you take this angle plus this angle, it equals this whole thing. So in other words, angle ABD, which is this angle, plus, I should say the measure of angle ABD, if I'm being technical, plus the measure of angle DBC equals the measure of angle ABC. I know that's really obvious and that's way over explained, but number 15 deals with that. They put a polynomial here and they put a polynomial here, and they say, well, what's the measure of the entire angle? Well, you take this polynomial plus this polynomial, clean it up, and then you get the whole thing, right? Basically, it's saying this wedge plus this wedge equals the whole thing together. Kind of dumb big red truck, but just wanted to explain that real quick. Your homework is section 7-6, and you got 1 through 15. 1 through 15. See ya.